Hey there, I'm Professor McBride, labor nurse, OB instructor, and your guide to everything OB. Let's get to it. Welcome to Everything OB Math Edition. Grab a paper and pencil and let's get started. These are the conversions and formulas we will be using. We're going to start by calculating the infusion rate in milliliters per hour. A patient with hypokalemia is to receive 40 milliequivalents of potassium chloride in 500 milliliters of solution over 4 hours. The IV solution is labeled 40 milliequivalents of potassium chloride in 500 milliliters of D5W. The nurse will program the pump to infuse at what rate? Since the amount of the medication in the bag is the same amount as the ordered dose, we will infuse the whole volume of the bag. So we don't need to worry about the contents considering the medication. We just need to look at the volume. The volume is to infuse over several hours, so we're going to use milliliters of solution divided by the total number of hours, and this will tell us how many milliliters per hour to infuse. So there's 500 milliliters of solution, and we're going to divide that by 4 hours, and we're going to find that our infusion rate is 125 milliliters per hour. Let's try another one where we're calculating milliliters per hour. The hospitalist orders 2 grams of Ancef to be infused over 1 hour. The solution is labeled Ancef 2 grams in 100 milliliters of normal saline. What rate in milliliters per hour will the nurse set the infusion pump to run? Again, with this one, the amount of the medication in the bag is the same amount as the ordered dose. So we will infuse the whole volume of the bag. The volume is to infuse over 1 hour. So we will use milliliters of solution divided by the total number of hours to get our milliliter per hour infusion rate. So we have 100 milliliters of solution divided by 1 hour, and we find that our infusion rate is 100 milliliters per hour. Let's calculate another infusion rate in milliliters per hour. The nurse receives an order for IV fluid hydration, lactated ringers, 1 liter over 6 hours. How many milliliters will you administer per hour? And it wants us to round to the nearest whole number. First, we need to convert 1 liter to milliliters since we will be administering in milliliters per hour. So to convert 1 liter to milliliters, we're going to take 1 liter times 1,000 and find that we have 1,000 milliliters. Now we will use milliliters of solution divided by the total hours to give to determine our milliliters per hour. 1,000 milliliters divided by 6 hours equals 166.6666. So it asks us to round to the nearest whole number. If we're going to round to the nearest whole number, we're going to look at the number just to the right, and that's going to be the number in the tenths place. If the number is 5 or larger, we will round up. And if the number is 0 through 4, we will keep that number the same. In this case, the number in the tenths place is a 6. Therefore, we will round up, and our total is 167 milliliters per hour. Let's try to calculate one using drop factor. A doctor orders 1,000 milliliters of normal saline to infuse over 8 hours. The IV tubing has a drop factor of 20 drops per milliliter. How many drops per minute should be delivered? Round to the nearest whole number. First, we need to convert the hours to minutes since we will be infusing in drops per minute. So we wanted to infuse over 8 hours, so we will multiply 8 hours times 60 minutes in an hour and find that it will be 480 minutes. Now we will use milliliters of solution divided by minutes to give times the drop factor to find the drops per minute. 1,000 milliliters divided by 480 minutes times 20 drops per milliliter. And our answer is 41.66666. Now remember that it wants us to round to the nearest whole number. Also remember from the previous problem that we are going to look at the number to the right of the number that we want to round to. And if that number is 5 or greater, we will round our number up. If that number is 0 to 4, we will leave the number the same. In this case, the number to the right of the nearest whole number is a 6, so it is 5 or greater. So we will round up and find the total to be 42 drops per minute. Let's calculate the infusion rate in milliliters per hour again. This time the prescription reads to infuse 500 milliliters of lactated ringers over 30 minutes. What hourly rate should the nurse program the infusion pump to run? We're going to use milliliters ordered over minutes to give times 60 minutes in an hour to solve this. So we have ordered 500 milliliters divided by our minutes to give, which is 30, and then times 60 minutes in an hour. And we will find that this total is 1,000 milliliters per hour. And that is our infusion rate to run over 30 minutes. Let's calculate another one in milliliters per hour. A patient is receiving 250 milliliters of lactated ringers in 20 minutes. The infusion is set to run at what rate? Use milliliters ordered over minutes to give times 60 minutes in an hour to solve this. We want 250 milliliters divided by 20 minutes, which is the minutes to give, times 60 minutes in an hour. And we get a total of 750 milliliters per hour to infuse over 20 minutes. Let's calculate an infusion rate for magnesium sulfate. A nurse is programming an infusion pump to deliver a 4-gram magnesium sulfate bolus in 20 minutes for a client who's in preterm labor. The solution reads 4 grams in 100 milliliters. At what rate should the pump run? Since the amount of the medication in the bag is the same amount as the ordered dose, we're going to infuse the whole volume of the bag. So for this, we're going to use milliliters ordered over minutes to give times 60 minutes in an hour. So the volume of the bag is 100 milliliters divided by minutes to give, which is 20, and then times 60 minutes in an hour. And we'll find that the infusion rate is 300 milliliters per hour to infuse over 20 minutes. Let's also calculate again with magnesium, this time with an extra step. The provider orders magnesium sulfate, 6-gram bolus over 20 minutes. The pharmacy sends 40 grams in 1,000 milliliters. Calculate the infusion rate to administer 6 grams in 20 minutes. For this, we need to use desired over half times volume to determine the infusion rate per hour. So what we want is 6 grams, and what we have is 40 grams. So 6 grams divided by 40 grams times the volume in the bag, which is 1,000 milliliters. And we find the total to be 150 milliliters per hour. This would be the infusion rate if we were infusing over an hour, but we want to give this over 20 minutes. So now we're going to use milliliters ordered over minutes to give times 60 minutes in an hour. So for milliliters ordered, we're going to give 150 milliliters divided by the minutes to give, which is 20, times 60 minutes in an hour. And we find that our infusion rate for this is 450 milliliters per hour to infuse over 20 minutes. Thanks for watching. Be sure to subscribe, like, and share for new videos every week about everything OB.
See you soon.